Chemical reactivity and storage presented. Former ammonium nitrate plant. Potential losses relating to chemicals. Property, fire, explosions, environmental release, workers' compensation, respiratory disease, dermatitis, chemical burns, physical injuries, general liability. Terminology: oxidizer, polymerization, reducer, pyrophoric, alkali, acid, explosives, reactive. Basic chemistry. Oxidizers want to gain electrons to be more stable, reducers want to lose electrons to be more stable. The stronger the oxidizer, the more it wants to gain electrons, the stronger the reducer, the more it wants to lose electrons. Strong oxidizers: fluorine, chlorine, ozone, persulfates, peroxides, perchlorates, dichromates, chromates, permanganates, hypochlorites, nitrates, nitrites, liquid oxygen. Chlorates. Reducers: finely divided metals, hydrazine, hydrides, hydrogen, aniline, sodium, lithium, potassium. Chemical state: solid, liquid. Water reactive chemicals: alkali metals, lithium, sodium, magnesium, hydrides, diborane, sodium hydride, peroxides, sodium peroxide, carbides, calcium carbide, oxides, sodium oxide, phosphides, aluminum phosphide, anhydrides, acetic anhydride. Polymerizable chemicals: chemical chain reaction of monomers to form polymers, may self-react, may react vigorously with water, may give off hazardous gases, may cause high pressure in storage container. Inhibitors are used to prevent reaction. Acrylic acid, acrylonitrile, ethyl acrylate, methyl acrylate, methacrylic acid, vinyl acetate. Unstable shock-sensitive chemicals, very unstable, react vigorously. Mechanical shock. Elevated temperature or pressures can cause reaction. Ammonium perchlorate, azo, diazo or azide chemicals, fulminates. Hydrogen peroxide, organic peroxides, nitro or nitroso compounds, picric acid, perchloric acid, triazines. S-sensitive compounds, reactive with oxygen in air, usually pyrophoric, usually stored under inert gas or liquid. Metallic dusts, zinc, nickel, titanium, alkali metals, potassium, sodium, magnesium, hydrides, diborane, barium hydride. Organic peroxides, compounds having two oxygen atoms joined together, peroxide. Severe fire and explosion hazard, burn rapidly and intensely, may be strong oxidizers. Plastics and rubber industries, used as accelerators, activators, catalysts, curing agents, hardeners, initiators or promoters. Solids, liquids and pastes can be formed spontaneously. Organic peroxides, methyl ethyl ketone peroxide, benzoyl peroxide, hydrogen peroxide, peracetic acid. There are many other peroxides. Spontaneous peroxide formation. Some chemicals can form peroxides during storage. Light and heat can cause peroxide formation. Prolonged storage of susceptible chemicals. Ethers, tetrahydrofuran, p-dioxane, 2, propanol, 2, butanol, methyl isobutyl ketone, styrene, vinyl acetate. indicators of intentional chemistry. Products have different chemical formulas than the starting materials. Gases are given off. Solid is formed from liquid or gaseous starting materials. A catalyst or initiator is used. Heat is generated or must be added to the process. Problems with intentional chemistry: wrong materials added, improper amounts of materials added, inadequate cleaning of equipment, materials added in wrong sequence, materials added too fast or too slow, contaminated feed materials, improper temperature of feed materials, air leaks, insufficient agitation, heat transfer inadequate, off-gas vent blocked or not open. Chemical spills waste. Assume all chemicals are reactive. Many fires start in dumpsters waste containers due to mixing of incompatible chemicals. Some reactions are immediate, many reactions may take hours or more. Waste segregation by type, spill procedures and training, hazmat procedures. Incompatible materials evaluation. Step 1. Determine if there are undesirable consequences, toxic gas generation, corrosive gas or liquid generation, flammable gas generation, formation of shock. Sensitive or explosive materials, explosion, fire, off, gas generation that can rupture containers, sufficient heating to cause runaway reaction. Step 2. Identify mixing scenarios, leaking containers, pumping into wrong storage tank, vessel, cross-connected line left open, material mislabeled or unlabeled, wrong materials selected by operator, waste materials combined in tank or container, waste material combined in saw. Contaminated raw material, residue from previous batch in equipment, cleaning materials left in process equipment, fire or explosion. Evaluation. Step 3. Provide controls to prevent mixing, training, segregation, engineering controls, chemical storage principles, segregation, protection from physical damage, hazard identification, fire control. Storage guidelines. Ensure containers are labeled. Segregate incompatibles by hazard class. Do not store alphabetically. Store flammables according to GC property guidelines. Do not store chemicals above eye level. Do not overcrowd shelves. Avoid storing chemicals on floor. Liquids should be stored in unbreakable packaging. Chemical segregation scheme. Compressed gases, flammable. Compressed gases oxidizing, acids, bases, flammable liquids, flammable solids, oxidizers, reducers, water reactive. Peroxide forming chemicals, poisons, toxins, carcinogens. Loss control evaluation of chemicals. Improper storage of incompatibles, leaking or deteriorating containers, spilled chemicals, temperature extremes, lack of or low lighting levels, blocked exits or aisles, security of storage area, trash accumulation, evidence of smoking, adequate ventilation, hazard communication program, employee training, waste handling procedures, hazmat procedures, intentional chemistry performed, fire extinguishers, sprinkler system. Warning signs, labeling, MSDSs. Label. Class 1, Explosives, Class 2, Gases, Class 3, Flammable Liquids, Class 4, Flammable Solids, Class 5, Oxidizers, Class 6, Poisons Infectious, Class 7, Radioactive, Class 8, Corrosives, Class 9, Miscellaneous. Health. For materials that can cause death or serious chronic injury with very short exposure. 3. Materials that can cause serious temporary or chronic injury with short exposure. 2. Materials that can cause temporary injury or possible chronic injury with intense exposure. 1. Materials that can cause irritation but only minor chronic injury. 0. Materials that cause no hazard beyond those of ordinary combustibles in a fire situation. Flammability. For materials that rapidly or completely vaporize at atmospheric pressure and normal temperature and burn readily. 3. Liquids and solids that can be ignited under almost all ambient temperature conditions. 2. Materials that must be moderately heated before ignition occurs. 1. Materials that must be preheated before ignition occurs. 0. Materials that will not burn. Reactivity. For materials that are readily capable of detonation or explosive decomposition at normal temperatures and pressures. 3. Materials that are capable of detonation or explosive decomposition but require a strong initiating source or must be heated under confinement, or explosively react with water. 2. Materials that readily undergo violent chemical change at elevated temperature or pressure, or react violently with water. 1. Materials that are normally stable but can become unstable at elevated temperatures or pressures. 0. Materials that are normally stable even under fire exposure and are not reactive with water. Chemical storage reactivity red flags. Peroxide, oxidizer, catalyst, accelerator, activator, polymerization, reducer. Chromate, dichromates, nitrate, perchlorate, nitric acid, chlorates, permanganates, hyperchlorates, persulfate, water reactive, nitro-azides, curing agent, hardener, initiator, promoter, acids, bases, unstable, pyrophoric,